Recording. Ayan. Resume record. Okay. Hello. So last time we are studying ano naman tayo sa slide mo. Okay. So last time we are studying the divergence theorem and we ended up dun sa right hand side ng equation natin. Okay? So yung left hand side nagawa natin, which is this one. Okay, very simple lang yung left hand side kasi yung divergence ng V is very straightforward, which is this. And then you'll have to integrate all over the volume, which is d tau. Then yung d tau mo, i-expand mo lang depending sa coordinate system mo. And sa coordinate system natin, madali lang kasi Cartesian. So dx times dy times dz. Okay? And then you evaluate that integral, bumalik tayo sa value na 2. Okay, and then sa right-hand side, meron kang 6 area kasi may dA ka dito. So, kailangan mo ng area. Meron ka ng, sa cube mo, meron kang 6 faces ng cube. So, meron kang 6 area. Okay? And then, since i-close natin yung integral, close the integral over the area, ang gagawin natin, isa-sum natin yung mga values na makukuha natin. Pag in-integrate natin yung integral natin per face or per side. So ito yon. So integral, close integral ng v that dA is given by this. So yung sa 1, yung sa 2, and so on and so forth, papunta sa 6, i-add natin lahat yun. So last time, umabot tayo sa 1 lang. Okay? So tuloy natin. Sige, tuloy natin. Para hindi tayo na ano. Okay, so sir, may tanong ako. Bakit nakatutok palabas yung mga vector areas mo? So, ganun yung convention natin, no? Pag nag-close tayo ng isang area, so radial yung vectors mo. Okay? So, nakatutok palabas yung mga normal vectors sa area mo. Okay? So, kung sphere naman to, ganun din, nakatutok din outward. So, mahirap lang pag planar, no? Kailangan defined yung area mo. Yung area vector mo. Kasi pag planar, di ba, plane lang siya. So, pwede siyang pataas o di kaya pababa. So, you have to be careful with that. Minsan, nilalagay naman yun sa questions usually, sa given. Okay, so balik tayo sa 2. Sa 2, okay, tingnan muna natin sa 2, ang area niya will be dy times dz. And then yung vector niya will be negative x hat. Tama ba? Kasi yung x hat dito, kung reverse ng 1 ay yung 2, ay di nasa negative x hat yung ano natin. Ayan. So, tuloy lang tayo. Sulat muna natin yung number 2 natin. Tapos sulat natin yung area para hindi tayo malito. Bale, negative x hat. Okay. Then same with the 1. So 1, same lang ng area niya. dy dz. Okay? Fairly simple. Then we have to do the integral again. V dot dA. Okay? And yung V natin is, balikan natin si V. Dahil nakalimutan ko si V. Ayan, mahaba si V, no? Sulat nga natin sa, so wala tayong space. Ugsog na lang natin. Ang point is, ang meron tayo ay x hat. So, since dot product naman ito, hanapin na lang natin yung x hat, no? Para hindi na natin memorize yung buo. So, yung natitira lang sa x hat ay yung y squared. Okay? So, integral ng dahil double dahil yung natin, yung infinitesimal values natin ay dalawa, dy dz, dalawa din yung integral natin. And yung bounds ng cube natin ay 1 lang, unit cube siya. So 0 to 1 lang. Okay? So kunin natin yung y squared, x hat, this is your v, then you dot product it with yung dA natin, which is negative x hat, dy dz. Okay. Ang laki ko pala magsulat. And this should be easy, no? Yung x hat dotted with x hat is just 1. So the integral is, negative. Tama. Nilabas ko lang yung negative, ha? Para hindi tayo maguluhan doon. Baka mamaya ma-minus natin. Nakakalito. So y squared dy dz. Daw, madali lang to integrate. Kasi y squared, integral ng y squared with respect to dy is just y cubed over 3. Okay, negative 0 to 1, y cubed over 3 evaluated from 0 to 1. Then, ang matitira na lang is dz. And this is just 1/3, di ba? And kapag in-integrate mo ulit with respect to dz, malalaman nyo na negative 1/3 yung sagot. 1/3 z, kaso evaluated from 0 to 1. Kaso pag pinlog in mo yan, ang lalabas lang din is negative 1/3. Okay, klaro? Yan. So, wait lang ah. Double check natin. Siyempre, mamaya pinagsasabi ko dito, mali naman pala. Pero siyempre, dapat hindi mali. Fundamental theorem. Divergence. Okay, double checking. Okay, tama naman. Plus, sir, parang nilalagyan lang natin yung negative sign. Ganun lang ba yun? Hindi, no? Magbabago yan mamaya. Okay, number 3, gawin natin. Number 3. Nagsasolve ba kayo? Saan nagsasolve kayo, no? Para...
Sir, question po.
Yes.
Yung notations, ang tawag dyan, yung mga sinusulat niyo po dyan sa OneNote niyo, sir, na pwede po ba yung ma-save and like ma-send as a file?
Hindi. Hindi ko rin siya alam paano i-export pa sa PDF or something. Hindi siya na-export. Ayun. So, sa YouTube naman, I mean, yung sa video ko na ina-upload, nakikita naman to. So, ayun. So, as much as possible, sabayan nyo na ako mag-solve para hindi na kayo magre-rewrite sa dulo ng ano, pag-exam na. Okay, tuloy tayo. So, number 3. Okay, yung direction natin will be, tingnan natin, ano ka-parallel niya, which is y, so y hat. And then yung area must be dz and dx. Okay? Okay. So, sulat lang natin, dA is, lipat na lang ako dun sa dulo. Kasi feel ko invasive na tong may invade niya na yung other slides. May invade niya na. Dito tayo sa dulo. Lagyan natin barrier. So, okay. Okay. Cute. So, balik tayo sa 3. Okay. Ayan. Ang dA natin, yung area natin will be y hat, then dx, dz. Okay? Anong meron tayo? Y hat. So, ipapartner lang natin si y hat. Hanapin natin kapartner niya kay b, which is, mahaba na. 2xy plus z squared. Okay? Ito. 2xy plus z squared. Balik tayo. So, the closed integral, the integral lang pala, sa v dot dA is just 2xy plus z squared. Tama ba? Tama pagkakaalala ko. Then, tinanggal ko na yung y hat kasi mag-multiply lang naman sila normally. Dx, dz, para mas mabilis tayo. Now, double checking, balik tayo. 2xy plus z squared. Okay, tama naman. So far, so good. Okay, mas mahirap na integral natin yan. No? So, kapag integrate natin to, magiging 0 to 1 ng Anong gusto niyo unahin? X na lang tayo, no? Magsudaling X. So pag in-integrate natin to, this will be, yung X natin magiging X squared over 2. Tama ba? Maka-cancel niyo yung 2. Yung X squared over 2, tapos maka-cancel yung 2. So that is just X squared. Kuha. And then Y squared. Kasi hindi siya apektado ng integral ng dx. And then yung dz mo, wala pa kasi,
Sir,
yes.
I think po yung ano yung sa y hat, sir, ano yan? 2xy lang po plus z squared.
Oh, to xy, yes, yes, yes. Oo nga. Galing, galing, galing. Oo nga, no? Nalito ako dun, na. Okay, thank you for the correction. Sige, burahin natin si y squared. Okay. Ayan. And then, ang tawag dito. Tutuloy natin yung integral sa z, maging x z squared, tama? And that is evaluated from 0 to 1. Matitira yung dz. This is just so pag zero natin, mawawala lang naman sila. So yung second term wala na. So evaluate na lang natin sa 1 natin, sa upper bound natin. So ang matitira will be y plus z z squared. Sorry. Okay, y plus z squared tapos dz. And then this is actually easy na lang din, no? So magiging yz plus z cube over 3. Okay, tama. And then evaluate mo sa 1 and 0, yung second term mawawala na. I mean, third and fourth terms. Kasi this is 2 term. So delete lang natin si z. Ang matitira is y plus 1/3. Tama? Okay, sir. Ano yung y? Ba't may y tayo, sir? Dapat di ba value lang makukuha natin? Hahanapin mo ngayon kung anong value ni y. Dahil nandito yung area natin, ang value ni y ay magiging 1. Okay? Amazing. So we have 1 plus 1/3. So that is 3 over 3. Sorry, hindi ako magaling mag-add ng fractions. Ginagawa ko laging ganito para hindi ako mahirapan. Plus 1/3. So that is 4/3. Amazing. Double check natin. Tama naman ako. Okay. Now, marirealize nyo ngayon na pag bumalik tayo, pag binaliktad natin, dito tayo sa number 4, yung area natin is along negative y hat, tapos same dx dz. It's not as simple as putting negative sign on your integral, di ba? Okay, so gawin natin si number 4. So dA will be just the negative of ito. Y hat dx dz. And then same pa rin si v. Fairly simple. dA magiging double integral 0 to 1. Tapos may negative sign ako. Nilabas ko lang. And then 2xy plus z squared dx dz. Alright? And then, by using the integrals na nakuha natin kanina, ganun din yung mangyayari. No? May negative sign ka lang muna dito. And then, copyhin ko to. Kasi integral ko ay with respect to x, same lang yung mangyayari. X squared y. So pag ganyan yung mga sa prob set nyo, pwede nyo invoke, di ba? Kaya nga tayo magsusulat ng equation numbers para madali natin ma-retrieve yung answer natin. So pag sinulat ko to ng mas madali kanina, kung sinunumberan ko siya, sorry, nilagyan ko siya ng star dito. So invoking star, ito na yung lalabas. I don't need to prove it. Okay, so evaluating lang from 0 to 1. And again, ulit lang tayo dito. Pero may negative sign ka. Okay, ito na yung negative sign ko. Pero copyhin ko lang din to dahil pag pinlagin ko si 1 kay x, ganun pa rin naman ang buhay ko. Alright, that is that. And kapag sinolve nyo to, ang lalabas is negative y plus 1/3. Tama? Okay, so baka magkamali kayo na malagay nyo lang negative sign dun sa isang term. So dahil kaya nilabas ko sa integral sign para yung buong integral, negative siya. So yung buong integral will result to y plus 1/3. So negative lang yun. And then I pick y. And looking back, yung y mo ngayon will be on this side, yung side na to. So there, ang value ng y natin is just 0. Tama ba? Kasi nasa origin ka. So yung y value mo will be just 0. And then evaluating that, I'll have negative 1/3. Very nice. Okay? Okay, last two. 5 and 6. So you see, no, ang point ng divergence theorem is kapag meron kang problematic na integral na to, the right-hand side natin nakakapagod gawin, di ba? But since at the later on stages of your electromagnetic theory, kuwari alam mo to, na-invoke mo to in your life, all these equations, mare-reduce mo siya into this one. Diba? Ang dami natin ginagawa, no? Ang dami natin ginagawa dun sa right-hand side mo. Pero on the left-hand side, napakadali niya. So, ayun yung sense ng divergence theorem, ng mga theorem natin na pinapresent ngayon para mapadali buhay niyo. Okay? So, ang galing nila, no? Ang galing nila Maxwell kasi ginagawa nila to. Dati pa. Hardcore. Well, ganun siguro pag boring yung buhay, walang internet. Anyway, tuloy tayo. So V tuloy. Sorry, 5 pala to. Sorry, ano ba yan, sir? So number 5 will be, yung direction mo is positive z. So z hat. And then yung area mo will be dx dy. Dx dy. Okay. So usog tayo dun sa dulo. Alright. 5 is, sulat mo again yung dA mo. Lagi kayong susulat ng ganito para pag na-lost kayo sa equation, madali makapag-backtrack. So z hat dx dy. Okay? And then z hat yung meron tayo. So check natin ulit ngayon yung anong laman ni v sa z hat. So 2yz. So pakialala. Magkamali na naman ako isulat. So yung integral ng v dotted with dA is just, so dalawa tayo. So 0 to 1, 0 to 1. And then 2yz. Tama ba? Oh my God. Nakalimutan. Z hat. And then dotted with z hat dxy dx dy. Sorry. dxy. Alright. And then we evaluate the integral in x. Pwede mong pagpalitin to, no, sa math 80 something nyo. Na-prove naman na pwedeng pagpalit-palitin yung mga integral. Kung gusto mo unahin yung dy, okay lang. Kung gusto nyo unahin yung dx, okay lang din naman. Walang problema. As long as in-evaluate nyo siya ng tama. Okay, so 0 to 1. Unahin ko yung x. So I'm left with 2xyz. 2xyz. Evaluated, of course, from 0 to 1 ng x. Yung x lang magbabago. And then, it is very straightforward na pag pinlog in ko si 1 sa x ko, I'm left with 2yz minus 0. So, tuloy lang natin. Ayan. So, ayan. I'm left with integral of 2yz. 2yz dz. Oh, mali sa ginagawa mo, sir. Bakit naging dz integral mo, sir? Balik tayo. Sorry. So, dapat dy to, no? Okay? Namalik mata ako dun. So, point out nyo pag ganun, no? Mamaya ako, ano nang pinagsasabi ko, hindi ko, minsan nakakalito rin. So, 0 to 1, ang maiiwan sa atin ay 2yz and dy na lang yung integral natin. And if we integrate y, magiging y squared over 2. Makakancel yung 2 ko. So, I'm left with y squared 2 times 1/2. So, cancel. May 1 yung z. And then, I'll integrate it with, I'll evaluate it from 0 to 1. And that gives me z. Okay? So, 1 squared is just 1. Y squared evaluated in 0 is just 0. I'm left with z. And yung value ng z natin will be, sa 5 tayo, so ang value ng z natin is 1. So this is just 1. Double check ako, and then, yeah, it's correct. Now, if we're gonna repeat the process for number 6, ang natitira na lang natin is yung dA na pababa, which I mean by pababa is negative z hat dx dy. Medyo intuitive na sa atin na pag inulit natin, mauulit lang din yung mga integral, no? Ang matitira na lang is yung may negative, yung negative sign. So, ganun pa rin naman, di ba? Same integral, ang may iwan lang sa dulo mo is negative sign. So, we skip the process. So, ayan, dA. I would say that this is just, yung final ko will be this one, but negative. So, negative z. Then, I'll evaluate it kung nasaan yung z mo. Okay, let's look back. Tingnan natin kung nasaan si z at number 6. So, si z at number 6 would be this lower face, itong nasa ilalim. And that is just z is equal to 0. Okay? Okay, so I'm left with 0. Now, the moment of truth, kailangan natin malaman kung equal yung left and yung right. So hanapin natin si number 1. Okay, mental lang tayo, no? Si number 1 ay 1/3. Negative 1/3. So 0 na tong 1 and 2. Tama? 0 yung 1 and 2. Okay, dali. And then si number 3, tingnan natin. Si number 3 ay 4/3. I-add natin sa number 5, which is negative 1/3. I mean number 4. Ito pala yung number 4. This is number 3. This is number 4. This is 5. And yung 6 natin 0, di ba? So 4/3 plus minus 1/3. That is 4/3 minus 1/3. So 3/3. Magiging 3/3 lang. So that is just 1. And I add it with number 5, which gave us number 1. So this is 1 plus 1. And we have 2. And ayun yung sagot ng left-hand side natin. Okay? So nagawa natin example, no? Check the divergence theorem. Okay, gumagana siya. Okay? So kapag naka-encounter kayo ng problems na tingin nyo na may lipat nyo sa ganitong form, feel free to use the divergence theorem. Okay? Okay. Minsan kasi problematic yung yung area mo. Minsan may mga problem na weird shape yung yung bibigay na ano, yung ibibigay na shape, weird siya. And mahirap siya geometrically pag sinulat mo na sa math. Okay, let's continue. So, ganun ulit. Gagawa ulit tayo ng panibago pang thing. So, pangilan na to? Ang apat na fundamental theorem natin will be fundamental theorem of curls. Okay, so kapag daw kinuha natin yung curl ng V, which is this, na mararamdaman mo over some area, dA, okay, so yung integral mo over that area lang, hindi closed yung area mo. Okay, so equal lang daw yun kapag pinakiramdaman mo si V along the boundaries of your area. So si DL, yung path nung dulo ng area mo. Okay? So amazing doon mga nakaisip nito na, nga no, ganoon lang pala yun. Pero syempre pinrove nila by hand yung math. Okay, so kung gusto nyo imagine ng ganun, okay lang naman. Pero pwede rin naman you take it as it is na ganito siya. Okay, ako I like to take it that way na yung curl mo, pag pinakiramdaman mo over some area, will be just the divergence of that on the boundary lines, DL. Okay, so may corollary tayo. Ayan, so mapapansin nyo, ito ay dependent lang sa boundary line, not the particular surface that is used. So parang yung gradient natin, wala siyang paki sa path mo. So tinry natin yun no, na pumunta from A to B. So ginamit natin yung 1 to 2 na path versus number 3 na path. And we obtained the same. Okay? So ayun sa corollary 1, na hindi siya nagde-depend on your surface that is used on the A. And then, ayan, yung sinasabi ko, kaya hindi siya closed kasi pag close mo na siya, mag-zero out yung boundary mo. Wala ka ng boundary, di ba? Wala ka ng boundary line, na-close mo siya. So yung DL mo, mag-shrink siya over a point. Ayan, like a mouth of a balloon. Ang galing mag-explain ni Griffiths, kaya maganda rin na basahin mo siya on your leisure time. Okay? Siyempre, ito na naman yung example natin na mahirap. Nakakapagod. Okay? So, suppose daw na we have this vector V. And check natin ang tawag din dito minsan is Stokes theorem. Okay? Or pag gustong pahirapan sarili mo, fundamental theorem of curls. But we can just have it as Stokes theorem. Ito naman, divergence theorem lang, yung shortcut niya. Okay, so let's continue. Example 1.1 sa libro nyo. Okay, check natin si Stokes theorem for this vector. For the square surface shown in figure 1.33. Okay, so ito yung figure 1.33 and gagamitin daw natin yung itong surface na to. Okay? Okay. So ano ba magandang gawin na una muna? Sige, left hand side na lang muna tayo para left to right tayo. So, kukunin natin yung curl muna ng vector V natin. So the curl is given by curl ng V is given by medyo hindi ko kabisado yung curl dahil hirap siya. So, okay. Gawin muna natin yung x hat. So, susulat ko siya ng ganito. Sulat natin siya. Lagyan natin boundary dito. Yan. Para pwede natin siya isulat on this part. Patayo natin siya isusulat para nakikita natin. Okay? So, partial ng, so unahin natin yung x hat. So, for x hat, parenthesis tayo, partial ng VC. VC is just yung Z component ng V mo. Okay? So, this part is your VZ. And derivative niyan with respect to Y is just 4Z squared. 4 z squared. 4z squared minus yung dy mo will be this one. Ay, wala palang x, no? Walang x na component, so mag-zero out lang to later. Okay, so solve muna tayo dito sa vy. Yung vy natin, which is this guy, mahaba, 2xz plus 3y squared. And if we take the derivative with respect to z, mawawala yung second term kasi wala siyang z. And then we're left with 2x. 2x plus yung y hat natin. And then, mawawala yung vx dahil wala namang vx. Balik tayo ulit sa vz. And that is just negative na so sa VZ mo, i-differentiate mo siya with respect to x. So that is just 0. Wala tayong 0 to. Oops, sorry. Z hat. Next. Tama, 0 lang to. No? So, lagyan natin ng slash. Ibig sabihin wala tayong napalagyan sa pangalawang term. So, Vy, ayun, meron na tayong x dito. Okay? So, sa Vy, ang partial derivative niya with respect to x will be just 2z. 2z. Tapos, itong last term is just 0 kasi walang vx component. Okay. Okay. Ayan. So, meron tayong dalawang term. So, delete na lang natin to no, para hindi nakakalito. Delete natin siya. Rewrite na lang din natin. 2z z hat. So, I'm just gonna rewrite things. Plus, oops, sorry. 2z z hat. All right. And what's next is yung kunin natin the left-hand side. So, idadot natin siya with the area. Sir, walang vector area. Okay. Nagdedepende yan ngayon sa path na kukunin natin. Dahil yung prescribed path is this. What is this? Counterclockwise. Gamitin natin yung right-hand rule. So, ipo-point out ko na yung normal area nito, yung kung saan nakatutok yung area nitong flat surface na ito will be on the x-hat axis. Okay? So doing the left-hand side, that gives me yung natin, sorry. Sikipan ako. Okay, so sulat muna natin yung bumalik siya. Sulat muna natin yung area, dA. That is just, gusto natin na nakatutok sa x-hat, so x-hat. Then yung area mo will be dy dz. dy dz. Okay? Okay, pag dinot na natin itong dalawang to, ang mabubuhay lang is yung first term. Okay? Kasi walang z hat dito. So, I'll write it down. 4z squared minus 2x dy dz. So, minultiply ko na yung x hat, no? Yung dot product ng x hat. Between x hat is just 1. So, tas ginawa ko na rin dalawa yung integral dahil dalawa yung infinitesimal element natin, which is dy dz. Okay, and now I just have to evaluate the integral. Then yung makikita natin na yung dy will run from 0 to 1, and then yung dz natin just 0 to 1 lang din. Okay, fairly simple. 0 to 1, 0 to 1. All right. Let's evaluate. Integrate natin dy. Madali lang dahil magkakaroon lang tayo ng mga y dun sa mga values natin, sa mga elements natin. So that is just, sulat natin, 4yz squared, 4yz squared minus 2xy. And then you'll have to integrate that or evaluate that. I mean, evaluate that from 0 to 1. And then I'm left with dz. Tama ba? dz yung naiiwan. So dy dz. And this is simple, no? This is, alam naman natin na 1 lang to, 1 lang to. And then if we evaluate them at 0, mawawala lang yung mga values natin. So we're left with 4. Sorry, the integral muna natin. Then, ang sikip. Yan, sorry. 0 to 1, then 4yz. Sorry. 4. Sa y natin in-evaluate. Okay, sa y. Okay. Ang usual notation kasi sa paggamit nitong bar na to is kuwari nalalagay na y0, y0. Pero tamad ako. So, ayun, nakakalito lang minsan pag nawala ka bigla in the middle of your solution. So going back, sorry, dami kong sinasabi na naman. Minus 2x, then dz. And then we'll have to evaluate again the integral. And from our elementary calculus, we'll have 4z cubed over 3. And this is just 2xz evaluated by at 0 to 1 ng z. So that gives me 4 thirds. 4 thirds minus 2x. Evaluate natin yung x. Bale, titingnan natin kung nasaan yung x natin, yung area natin. And yung area natin, makapansin natin na yung plane natin is just on the x equals 0. And that gives me 4 thirds. 4 thirds. Okay? So I'll have to check. Tama naman. 4 thirds yun sagot. Pero ang problema naman natin ngayon is yung pagkuha nitong right hand side. So ngayon, i-breakdown ulit natin no yung closed closed path natin. So that is yung path natin. Oh, sorry. P dapat. Then yung V dotted with DL, the path, is just yung sum ng from 1 plus 2. And then kulang tayo sa space. So usog natin. Plus 3 and plus 4. Nung V dotted with DL. Okay? Okay. So madali lang itong path natin kasi ayun, dx, dy, then dz, then another dz, dy again, then pabalik ka ulit sa origin mo. Okay, let's start. Gawin natin para hindi tayo nalilito. So sa start tayo sa 1, yung dl natin is just dy. Okay? Okay? So, sorry, nawawala yung pen ko. Okay. So, sa 1, dl will be dy y hat. Ang pangit. Ayoko ng ganun. Y hat dy. Okay? Double check ko lang para so we evaluate the integral, okay? Sulat natin yung integral natin. Dotted y hat dy. Okay. Now, kailangan natin tignan ngayon no, yung v natin. Kasi mahaba yung v natin. Which is this. Oh my God. But, pwede na natin i-simplify agad since we know that yung path mo just lies on the x is equal to 0 and then z is equal to 0 kasi nandito lang yung line mo. So, I'm left with 3y squared lang sa y hat mo. Okay? Malinaw ba yun? Kasi itong line na to, nasa x is equal to 0 siya and z is equal to 0 lang din. Okay, so ipa-plug in ko na agad. Ang ginagawa natin dati is pina-plug in natin sa dulo yung mga values ng matitirang variable. Pero pwede naman natin gawin in the sa simula yun. Okay? So gagawin natin ngayon yun para hindi tayo mahirapan. Okay, so wala na yung first term. Ang maiiwan na lang is 3y squared. So I'm left with 3y squared integral ng 3y squared dy. And yung path natin is just from 0 to 1. We're left with, this is simple, y cube over 3. And nakakancel yung 3. So that gives me y cube evaluated from 0 to 1. And that is just 1. Tama ba? Okay? So double check ko. Tama naman. And then tuloy natin. Madali lang naman. So yung 2. Sulat natin yung path natin. Tingnan natin ngayon yung path natin. Sa 2 ay dadaan tayo ng z hat. So ang path natin will be dz directed to z hat. And I'm left with doing the integral. Titignan ulit natin what happens. So sa z hat natin na part, ang meron ay 4yz squared. And if we look at y, we can see that yung y natin is situated on 1. Okay? So I can plug in 1 on 4yz. I'm left with 4z squared. 4z squared. Oops, sorry. Z squared, 4z squared, z hat times z hat dz. So this is just that. And yung bounds natin will be 0 to 1. Sorry guys, nakakain ko lang, dumidikay-dikay ako. Okay. Tama, di ba? 0 to 1 kasi this is just z is equal to 0, yung lower part mo, and z is equal to 1. So from this, 0 to 1 is z mo. Okay, and this is fairly straightforward. This gives me 4z cubed over 3, evaluated from 0 to 1 again. And this gives me 4/3. Okay? Okay. So, usog tayo dito sa right-hand side natin. So, drawing tayo ng boundary line. Boundaries. Let's do number 3. So, ganito sa electromagnetic theory, nakakapagod mag-solve talaga. But it enhances your brain. Number 3, okay. Ang number 3 natin will run from dy again. But this time, yung value ng z mo is 1 na. Okay? Okay. Okay, sulat natin yan. So, dl, yung path mo, will run from negative y hat, dy. Okay, tama ba? Okay, sige, sulat ko muna. And then, ipapattern na lang natin to sa v natin. So, y hat lang yung kailangan natin. So, this one, y hat. And we're left there with Pa-plug in ko na si Z kasi 1 lang si Z. So 2x plus 3y squared. Okay? Remember that 2x plus 3y squared. Oops. May value na din pala yung x, no? So yung value ng x, 0 nga pala. Sorry, kasi nandito yung plane natin. So hindi na natin kailangan pahirapan sarili natin. Kung natin, tanggalin na natin to. Kasi z is equal to 0, x is equal to 0, and yung matitira sa atin is 3y squared. 3y squared. 3y squared, negative dy, and then yung integral mo will run from, will run from 1 to 0. Okay? That's a different thing now. 1 to 0. Okay? Let's do this. Ang matitira ay 3y squared. Integrate natin si y squared, y cubed over 3. Maka-cancel si 3. We're left with y cubed, negative y cubed. Evaluate, wala na palang over 3 kasi na-cancel na over 3. Evaluated from 0 to 1. So, evaluate natin to. This gives me negative minus 1. So, that is just 1. Okay. Okay, guys. Apparently, kapag sinulat mo pala si D sa path mo, ayun, so ito sa mga part na nakakalito in electromagnetism is yung pagsulat mo ng mga paths mo. Okay? Okay. So, kapag line integral tayo, hindi mo na kailangan isulat yung direction mo dito. Pipili ka lang kung saan mo ilalagay yung direction mo. Okay? So, ang point ko is, pag sinulat ko na negative na dito sa una, dapat yung integral ko 0 to 1. Okay? Okay? So, that's my fault, no? Na doble ko pala yung pag-change ko ng integral. Okay? So, okay. Ang gagawin ko ngayon is, dahil comfortable to gamitin, di ba? Kasi alam mo na si DL mo will run from negative y hat, as you can see here, papunta siya sa y, negative y hat. So, i-retain ko ngayon si DL, yung path natin, kasi ito ay may geometrical implication na sa utak natin. So, madaling isipin yung negative y hat dy. Okay? And then yung dy mo will be just normally 0 to 1. Okay? 0 to 1. So, ang point lang is yung range ng dy mo, yung values ng dy mo is 0 to 1. And then, magbabaliktad lang naman to. Okay, so note that ha, pipili ka lang ng isa kung anong gusto mong path. Okay, pwede mong baguhin yung integration path mo or yung baguhin mo yung DL mo. Okay? Okay. 0 to 1. And that gives me negative 1 na lang. So that is just negative 1. Okay? Negative 1. Negative 1 minus 0 to. So negative 1 lang. Alright. Okay? Malinaw ba yun? Alalahanin nyo na. Di ba? Nakakalito. Okay, sa path number 4, let's do this. Last one na to. Nakakapagod, di ba? Ulit. DL natin, again, gusto ko i-retain yung geometrical importance nung makikita nyo siya dito. So that is just negative z hat dz. Okay? Negative z hat. Tama? Negative z hat, tapos dz yung line mo, yung path mo. And then, dahil z hat lang meron tayo, titingnan natin ngayon yung z hat. Ooh. However, yung y mo at this line, so number 4, is just 0. Okay? So, integral ng integral ng 0 dz evaluate from 0 to 1 is just 0, di ba? 0 to, di ba guys? Naniniwala ba kayong 0 to? Alalahanin niyo yung math niyo. Hindi to ano hindi to z evaluated from 0 to 1. Hindi mali yan. Kasi pag mangyayari lang to kapag constant yung value mo. dz. Tama? So, factor out mo yung constant mo dito. Constant mo. Tapos integral ng 1. Now, this is integrable by, pwede natin ito integrate by z. However, kapag 0, wala ka talaga makapala. So, this is just 0. Okay? 0. 0. Okay? May narito ba dun? And then, of course, ang point natin is i-add tong 4 na ito. So, 1 minus 1, that is just 0. And then, ang natira is 4/3. Now, is that the same as... Okay, hindi pa pala natin ito integrate na ba natin ito? Ito pala. In-integrate na pala natin itong left-hand side natin. So, yung left-hand side natin is 4/3. Tama? Dahil ito yun. Ayan. Tapos 4/3. Mapansin natin na equal lang din siya din sa right-hand side. And that is the point of the exercise or the example. Okay. So, 1 minus 1 plus 4/3 plus 0 is just 4/3. Okay. Equal na. Okay, so ayun yung mga fundamental theorem mo in your del operator. So may curls, may gradient, may divergence, and you can use it in the future problems na gagawin natin. Okay? Okay. Now, punta tayo ngayon sa Dirac delta function. Pero i-consider muna natin yung vector na ito. Yung vector na 1 over r squared r hat. Now, what does this look like? So, yung vector na v, ulat natin, v mo is 1 over r squared. And then, direction niya is r hat. So, pag sinulat mo siya sa, sulat tayo ng coordinate system. Kapag inisip mo to, so yung vector mo will radially point outward. So, tama. Radially point outward. And then it decreases as you go along infinity. So, lagyan pa natin dito. So, lagyan natin ng broken line. Ibig sabihin lang humihina siya as you go farther from the origin. Diba? Parang, ito ay parang gravitational field. Diba? 1 over r squared yung gravitational field natin. And as we go farther from Earth, nawawalan ng gravity. Humihina. Okay. So my point is, kapag ginawa natin yung divergence dito sa part na to, dapat it gives us a value. Diba? Kasi ayun nga yung point nung Okay, may nagtanong. Sorry. Minto ako. Pero sige, tuloy ko muna. Ang point ng divergence is something that diverges or changes as you go farther along or increases as you go farther along. And this does increase or decrease. Increase as we go farther from the origin. And intuitively, dapat yung divergence natin is non-zero. Okay? Note that in your mind. Pero tapos, iti-take muna natin itong question natin. So, sir, question po. Tama po ba na hindi closed yung surface na ginamit sa square path sa previous example since hindi po zero nakuha natin sa left hand and right hand side? Ano po yung considered na closed surface po if ganun, sir? Ang ibig sabihin ng closed surface is 3D yung surface mo. Okay? So in 2D, hindi ka makakabuo ng closed surface. Okay? Kaya ito yung ginamit na surface kasi doon daw yung ito yung given na ito yung tanong given sa atin na square surface daw and shown in figure 1.33 which is this. So itong square surface na ginamit natin. Okay? So kaya natin ito ginamit kasi tanong siya. And then ano yung considered, sir, na closed surface? Yung closed surface is this one. Diba? Cube siya. 3D siya. And lahat ng sides ng cube, meron kang area. Meron kang surface. 6 surfaces. And magkakadikit lahat sila. Okay? So, ganun yung mga closed surface mo. Pwedeng spherical shell. Ganun. Cube. Rectangular prism. Ganun yung mga surfaces natin. And ayun, sabi nga sa corollary natin na kapag yung napiling surface is closed, then this would mean that yung theorem, Stokes theorem mo will just zero out. Okay? Kaya in essence, hindi useful ang Stokes theorem sa mga closed surface. Okay? Okay. Nasagot ko ba yung okay yan, nasagot ko yung tanong niya. So tanong lang kayo, no? Lalo na pwede nyo private yung tanong natin. Private nyo yung tanong niya para kung nahihiyaman kayo magtanong, okay lang. I-broadcast ko naman sa klase without broadcasting your name. Okay? Okay. Okay, so going back. So sinabi natin na intuitively, dapat may divergence yung function na ito. So let's apply divergence theorem. Siyempre, di ba? Kung may divergence, pwede natin gamitin divergence theorem. So in left-hand side, gawin natin, let's take the divergence of this function. Okay? Sa left-hand side, gawin natin yung divergence. Now, yung divergence ko, papalitan ko siya ngayon ng spherical coordinates. Ito, nasa likod ng libro niyo yan again. Kasi, yung given natin is in spherical coordinates. So, ipapattern ko lang dahil mas madali gawin yun. So, hindi na ako magta-transform ng variables ko into Cartesian coordinates. Lalo na I've given with this. Okay? So, ang function natin is this one. So, v over 1 is equal to 1 over r squared, r hat. And mapansin natin, wala tayong theta and wala tayong phi na variable. Okay? So, kung wala yun, wala tong mga terms na ito. So, gawin natin yung divergence. Okay. Let's do the divergence. Divergence ng v is just, kopyahin ko lang, 1 over r squared, partial ng r, r squared v of r. R squared vr pala, sorry. R squared. Ano yung VR natin? Ano yung component yung R natin? So that is just 1 over R squared. Okay? Okay? Kuha. This is 1. What happens next? 1 over R squared. Halakas, sir. Partial derivative ng 1. 0. 0. Okay. Hala. Sir, di ba sabi nga natin, Dapat magkaroon siya ng value kasi nagda-diverge siya from the origin. Okay, okay. Panic muna tayo konti. Tingnan natin ngayon yung right-hand side. Okay, so yung right-hand side, gawin natin. This time, we take the spherical shell. Ayan. Ito, closed surface na naman tayo, pero spherical shell. Okay. Oops, sorry. Okay, spherical shell. So, to do that, okay, tandaan nyo tong lesson na to. Ha? Sa DA natin, ang mangyayari ngayon, surface mo, since it is a spherical shell, constant yung radius niya. Tama ba? And we take that radius to be R. Okay? And then, kapag may shell ka, hindi nagagalaw yung radius mo dahil constant na nga siya, and bubuuin na lang siya nung dalawa mo coordinates, which is just theta and the phi. Okay? Now, this makes up our area. The point, ang problema ngayon is yung vector mo. Okay, so yung vector natin will be, again, sinabi ko na from yung cube natin, laging outward yung vector mo. Vector directions mo, outward. In the same way, ganun din yung dito mo. Okay, wait, is this correct? Dahil curved yung surface mo, dito sa d theta, d phi, kung maaalala nyo sa math lessons nyo dati, kailangan mo ng scaling functions or kailangan mo ng scaling factors to account for the curvature. Okay? So kasi sa usual natin na area, di ba? Ang area is just side times another side. Pag square shell, length times width. In the same way, kung theta at phi, parang ganun lang din. Pero ito kasing pag curved coordinates ka na, kailangan mo ng scaling factors. Okay? So, ang scaling factor ng isang sphere is r squared sine theta. Okay? R squared sine theta. Okay. So, ito na yung buong DA mo. So, take note to na lagi yan. For a spherical surface, spherical shell of radius r, of radius r. Okay? So, ganyan lagi. Alright? Noted by one? Okay. So, tuloy natin. Gawin na natin yung integral natin. So, dito na lang tayo. Hindi na tayo magkakamay dahil madali lang naman. So, V, ito yung V mo, .dA. Sir, bakit naging capital R yung V mo? So, ganun lang din parang kanina, ini-evaluate natin kung nasaan yung area natin. At this point, kung nasa area tayo na number 3, yung values mo ng Y is 1, di ba? Tapos gagalaw na lang si X and gagalaw na lang si Z. In the same way, ganun lang din dito. At the edge of the spherical shell, ang value ng R will be the radius R. Tama ba? So we plug in that here, R squared. And then R hat dotted with R hat is just 1. Tapos magka-cancel lang yung R squared mo. And then you can do the integrals easily. Okay? So sin theta, integral nun, d theta. Sin theta, d theta, integral nun will be negative cosine. So negative cosine evaluated at pi. That is negative 1. So that's positive 1. 1 lang to. Tapos, tama ba? Oh, pi. Tapos, so negative, gawin natin, parang tayo malito. Wala, so ikaw lang yung nalilito. Charot. Gawin natin yung sine, 0 to pi, sine theta, d theta, para Di tayo malito. So cosine, negative cosine theta to, no? Negative cosine theta evaluated from 0 to pi. And this gives me, so ko lang, sorry, negative cosine pi. Negative cosine pi. Ala, sir, anong sulat yan? Sorry, sir. Pi, sir, pi. Okay, cosine pi. Tapos, minus cosine 0. Okay? Cosine pi is negative 1. So, this is negative 1, negative 1. Tama? Negative 1. Dami negative na nakakaloka. Negative, positive yan. Plus cosine 0 is 1. Negative 1 is 1. 1 plus 1, 2. Okay, 2. So 2, itong value na to ay 2. And this is pretty straightforward dahil wala namang variable doon. That's just a constant 1. So integral nun will be just phi evaluated from 0 to 2 pi. And that gives me 2 pi. So 2 pi times 2 is 4 pi. Okay, makes sense na to, no? Hala, may value na, sir, yung divergence ano natin. Dapat may value yung sinasabi nating divergence ng function na to. Pero bakit yung left-hand side natin, 0? Bakit yung left-hand side, pag ginawa mo yung divergence niya, magiging 0. Hassle naman nun, sir. Bakit gano'n? Bakit hindi gumagana dito? Sira ba yung divergence theorem natin? Okay. So, mathematicians resolved this, si Dirac. So, we have the Dirac delta functions, and it is defined in this way. Okay, so the divergence ng r hat over r squared will be 4 pi. Dirac delta, yung cube niya, with respect to r. O yung r mo will be yung kung ano mang coordinate system na ginagamit mo. And in this case, pwede natin siya isulat as yung x, y, z. Okay, what does this do? Kung hindi natin ito mag-gets, no? Kung hindi natin alam yung definition ng Dirac delta. So we go discuss the Dirac delta function in the one-dimensional space. Amazingly, yung Dirac delta function mo, ito, is defined in this way. It's 0 kapag hindi siya nasa x. Ay, kapag hindi siya nasa 0. Okay? So, hala, may tanong. Sir, paano po nakuha yung ang tinutukoy ba nito, ang tinutukoy niyo ba na, sorry, hindi ko pala na ano yun, inassume ko na alam niyo. Tinutukoy ba na bounds is 0 to pi and 0 to 2 pi? Tama ba? Can you check it? Can you chat with me? Yes. Okay. Okay, so pakita ko lang yung spherical coordinates natin kung paano ba siya nag-work. Okay? So, we have x, y, and then z. Y, z. Okay? So, kapag gawa tayo ng cute na panulat. Okay, so yung r hat mo will be this guy. Tama? Yung radial vector mo will be that guy. Okay? And then, para mabuo yung sphere, kailangan mong buuin yung... So, kailangan umikot-ikot nitong si r hat para mabuo yung sphere natin, di ba? So, iikot muna tayo along xy. So, along xy, if we do that, if we rotate this much, gaano kalaki yung rotation na magagawa natin? So that is 0 to 2 pi. So yung theta natin will be defined as something like this. So sulat natin yung top view natin, top view nung bagay na to. So ayan. Top view tayo. Nasa top view tayo ngayon. And then titingnan natin si r hat from the above. Pag tinignan natin siya from above, r hat, yung theta will be defined here. Okay? And if we rotate a whole circle, that is just from 0, itong line na to, 0 pi over 2, pi, 3 pi over 2, and that is 2 pi. Sorry. Ayaw gumalaw. Oh my God. Yes. Yes, ayaw niyang gumalaw. Yan. Okay. Wait lang. I-check ko lang muna kung anong coordinate system paano ginamit ni Griffiths yung yun. So, kasi ako ay by okay. So, baliktad pala ako ng notation. Okay, let's do it again. Sorry. Ang pinagkaiba lang naman is yung notation lang namin. So, ang ginamit niya pala is wait lang. Oh shit, nabula. Sorry. Slowly lang, sir. Yan. Okay, ang pinangalan niya pala sa angle between the x hat and the y hat is phi. So pag umikot ka, that will be 2 pi. Okay? Okay. So that is here. So, ayan. Okay? So 0 to 2 pi, nakuha na natin kung anong sense niya. Now that we have a ring, sige, mag-ano naman tayo, side view. So gawin natin side view yung x hat and z hat. Oops, sorry. Yan, x hat and oops, kailangan palang palit ng color. Ayan, so z hat. Tapos nakatusok pa loob yung y hat. Tama? Nakatusok siya pa loob. Ayan. Okay? So, sulat lang natin. Para hindi tayo malito. Okay. Imagine natin ngayon itong circle na nagawa natin. So, drawing ko lang na yung circle natin. Kuwari, lies in the, ano, diba? Yung circle natin na nagawa is lying down in the XY plane. So, here, sorry. Ay, dapat pala yung rainbow na yung gagamitin natin. So, kung inikot na natin si R sa phi natin, so makakabuo tayo ng something like this. Okay? Makakabuo tayo ng ring here. Na-imagine nyo ba na may ring tayo dito? And if we're trying to build the sphere, dapat makakabuo tayo ng ring, another on the top, getting smaller, getting smaller, getting smaller, and another one at the bottom, getting smaller, getting smaller, getting smaller. Ang point is makakabuo ka ng sphere if you continuously build rings. Okay? And from that, syempre, kailangan natin ng integration bounds. Yung integration bounds natin will be from this guy. So yung phi natin will be defined as something like this. Okay? Ayun yung ano pala, theta pala natin. Sorry, nalilito talaga ako sa arrangement niya na ano. Okay, so yung theta natin will be like this. Okay? So, ang bubuin mo na lang para, kuwari, gusto mong gumawa ng ring dito. So, ang point is, gagalaw tong si theta para makabuo ka ng rings from top to bottom. And to do that, ang kailangan mo lang is to run from positive z hat to negative z hat. Di ba? Hindi mo na kailangan bumalik. Hindi mo na kailangan bumalik pa ganun. Kasi pag bumuo ka dito, may ring ka na, may ring ka na, may ring ka na, may ring ka na, and so on and so forth. Nabuo mo na siya. Okay? And this is just 0 to pi. From 0 to pi. Okay? So yung ring natin, nabuo natin siya dahil 0 to pi yung 0 to 2 pi yung andar natin. And then bubuuin mo naman from top to bottom. So ang bounds lang nun will be 0 to pi. Okay? Kuha ba? Okay. So mag-upload ako ng detailed drawing niya kung gusto niyo pang mas actually I can do it right now. So dinrawing yan ni Griffith sa libro natin. And this is just here. I added here. Oops. Sulat lang natin. Sorry. Para hindi tayo mahirapan. Ayun. Nag-paste na siya. Ayan. So, ayan. So, ayan. So, makikita nyo sa libro yung figure 1.36 kung paano niya binuo yung curvilinear coordinates niya. Okay? Sorry, sir. Napahaba pala. Okay lang yan. Pag may nalilito kayong tanong, okay lang na umulit tayo para we can go along. Okay, going back to the Dirac delta function. So, ang Dirac delta function mo, hanggat hindi siya tumatama sa 0, wala siyang value. Okay? So, at 0, ang value niya infinity. And kapag wala siya sa 0, if not 0, ang value na lang ay 0. However, a special thing happens when you integrate it. Tapos nadaanan mo ngayon yung 0. Okay? So, ito, kunyari example, negative infinity to infinity. Madadaanan ko ba yung 0? Yes, madadaanan ko yung 0. And if that happens, my value, the integral of the Dirac delta function becomes 1. Okay? Okay, so suppose iusog natin yung Dirac delta function natin by a value of a constant a. So kapag wala si x sa a, 0 lang siya. And then kapag na-hit niya na si a, magiging infinity na siya. Anong sense nun? Pag ginawa mo ngayon yung integral na representation niya, it will become like this. Okay? So kapag since negative infinity to infinity tayo, madadaanan surely yung a. So that gives me 1. Okay? So ang sense nun comes like this. If natabihan niya yung isang function f of x, ayan, nakatabi niya yung function f of x, ang mangyayari, since gagalaw yung x mo, di ba? Gagalaw yung x mo all over your space, dx. Tapos, si Dirac delta, since 0 lang naman siya elsewhere, kapag hindi a, ang mangyayari sa integral na ganito is mauusog mo lang si x towards a. Okay? Amazing, no? Siyempre, mag-example tayo para mag-gets natin yung ano man kalokohan nangyayari dito. Okay? So, tandaan natin, kailangan madaanan ng integration bonds mo kung ano mang an argument ni Dirac delta function mo para magkaroon siya ng sense. Otherwise, magiging 0 lang siya. Okay, let's do this example. Napakadali lang ito. So, there's a lot of examples in your book. You can try that. Okay, 0 to 5. This is just example. Cosine x, Dirac delta. Lagyan natin ito. Dirac delta x minus pi. The dx runs from 0 to 5. dx. Okay, let's investigate the argument or the value inside the parentheses of the Dirac delta. So, ayun, tawag natin sa mga nasa loob ng parentheses or yung function mo is the argument. So, ang argument ni cosine ay x. Ang argument ni Dirac delta ay x minus 5. Okay, so terms lang, terminology. Kasi baka may sinasabi ako na hindi nyo mag-gets. So, tingnan natin yung argument ni Dirac delta, x minus 5. Okay, so na-shift siya by pi. Ang tanong ngayon is yung x ba natin, yung dx natin, madadaanan ba sa integration yung pi? And since pi is just 3.14, so madadaanan somewhere sa 0 to 5. Okay? So we are allowed to do this. Cosine pi. Okay? And the cosine pi, ang value niyan will be negative 1. Okay? So, ayun yung sense ng Dirac delta. Okay. Now, let's do another example. So, we have this. Show that yung Dirac delta mo, pag yung argument niya, kx is just 1 over the absolute value of k times x. Now, okay. Nice question. Sir, kung mas malaki po ba yung bounds as long as covered po nito yung pi? Same answer lang po. Yes. Okay? Same answer lang. Yes. However, kapag ginawa natin to, ginawa natin 0 to 2 lang. Cosine x Dirac delta x minus 5 dx. Yeah, this is just 0. Okay? Because your Dirac delta just vanishes along these values kasi hindi niyo inabutan yung pi. Okay? Okay? Okay, now let's do this. Sir, this is easy kasi pag dumaan lang si x, dumaan si x 0, dapat maglalako lang din ito. It's not as simple as that kasi hindi naman natin na-define itong bagay na ito. Ang defined lang is yung walang minumultiply sa x. Okay, so we'll try to do that by saying na kunyari, we have an integral from negative infinity to infinity. And then, sabihin natin na may function tayo na f of x, kx, integrate natin siya. Integrate natin siya, dx. Okay, now hindi ko alam paano gagalaw to. Okay? Alam natin na, okay, dadaan siya sa 0, but hindi nga natin alam kung paano defined or paano gumagana tong bagay nito. So we have to do something like this. So let's say we have y is equal to kx or any other variable. Sulat ko lang na para mapalitan ko to, di ba? So then we have the derivative of y is just k dx. And I'm going to do substitution. So this will become negative infinity to infinity. Yung f of x ko magbabago, tama? Magbabago, that will be so yung x ko will be y over k. Okay, tama? Y over k. And this is just y. Yung dx ko will be dy over k. Okay? Okay, alam na natin to, di ba? We defined this earlier. Okay? However, mapapansin natin may unting complications tayo na kapag, sir, paano pag positive si k? Paano pag negative si k? Okay, so pag positive si k, di ba yung dx natin, dx runs from negative infinity to infinity. However, if we have k as something that is negative in value, magsuswitch ngayon si y mo. Okay? Nagets ba yun? Magpapalit ngayon yung integral bounds mo from negative infinity to infinity. Magsuswitch yan ngayon balik. Okay, let's note that for a while. If k greater than 0, we have something like this, the normal one, f1k the integral Dirac delta dy over k. Ay, kinopya ko lang. Okay, may tanong pa pala. Sorry. Sir, what if nasa bounds po mismo siya mismo ng integral so? Okay, ang tanong ay what if 0 to pi? Tama ba? Paki-chat naman kung tama yung nasa isip ko. Kung tama yung pagkakagets ko sa tanong. Okay, pag 0 to pi, yes. Available pa rin to. Ganito pa rin ang sagot. Okay? As long as madadaanan siya, that's good. So, nasulatan ko pala. Okay.
Pinupost po niyo sa yung recording. Kasi,
Ano raw? Sorry. Are you okay, Elijah?
ay sorry sir.
Na-unmute mo ata yung mic mo. Okay lang yan. Kinabahan ako. Kala ko na-post yung recording. Ayun sabi niyo, di ba? Okay.
Sorry sir.
Okay lang yan, okay lang. Okay. So, balik tayo. If k less than 0, ang mangyayari ay negative, or balik tayo natin yung bounds para mas clear. This is f, y over k delta y dy and let's write this down as negative the absolute value of k. Gets ba? Bakit ko ito ginawa? Para sure na itong entity na to is negative k lang. Okay? This is satisfied. And kapag pinansin nyo, I'll simplify this. Ilalagay ko ngayon yung negative dito. I-absorb ko siya sa integral bounds natin. And that would mean switching the integration bounds. Tama ba? Naalala niyo sa math niyo yun? Wala sir, hindi na kita nagigets kung bakit nagagawa ng ganito. Okay? 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 Gets? Pinasok ko lang yung negative sa integral bounds natin. And yung effect nun will be switching them. Okay? And I could say na okay, sir, bakit ginawa mo to dito sa part na to but not on the f function natin? Sige, gawin din natin. Doesn't matter. Yan. Okay? Ilagay na natin. Okay. And then, sulat ko lang din to. Now, does it matter? If k is positive, I can just put an absolute value to that k. Since k is positive anyway, right? I can do this freely. dy, since k is positive, I can do this. Are they the same? Not yet. Not yet. Di pa. Di pa natin yung same din. Kasi f natin, sir, magkaiba. Wala tayong magagawa din, sir. Ngayon, gagawin ko ngayon yung power ng Dirac delta natin. So when we have this, we know how this works. Wala nang constants katabi si y ngayon. And si dy natin dadaanan si 0. And we have something like 1 over k tapos f of 0 1 over k f of 0. Kuha. Kasi, di ba, ganun lang naman power ng Dirac delta natin. Since hindi naman shifted, so ang point niya pa rin is sa 0 sa kung saan siya magkakaroon ng value. Okay. Okay. And then, let's look at a similar thing. What if we have something like this? F of x, Dirac delta of x, and then divide, ano lang to some random stuff lang. If we have something defined like this, then we try to evaluate it. What happens? When we evaluate this, alam natin to. This is Dirac delta of x, diba? Gagalo, since yung x mo is from negative infinity to infinity, madadaan niya sa 0, and we have something like 1 over k f of 0. Tama ba? Okay. So this is a different function, di ba? This is a different function. This is a different function. But in essence, the right hand side is the same. So in essence, let's write it down. Na yung f, ito, copying ko lang nasa taas ko, f of x is also equal to this guys, di ba? Di ba? Yung mga inuna natin. And kapag magba-backtrack ka, saan ba nahugot yung problem na yan? Magba-backtrack ka, dito siya mapupunta. Ay, sorry. Ano ba yun, sir? Mag-backtrack tayo. Original problem natin is something like this. Partial tuloy. Dirac delta of kx dx. We know that this, kapag inayos natin with the variable substitution, this will end up to these two guys, which is the same. And if we have another problem, na pag sinulat na ganito, we'll have the same answer as this. Then, by the laws of mathematics, di ba? Kung equal yung right-hand sides nila, therefore, equal yung left-hand sides nila. So, these guys are equal. And kapag in-eyeball natin to, since may pantay yung integration bounds mo, pantay si f of x, pantay si dx. This gives us that the Dirac delta of kx is just equal to the Dirac delta of x over k pala to dapat. Ba't naging x siya? Ano ba yun siya? Okay. Absolute value. So I'll just clean this up. This is k dapat. Nakapagod pala magsulat. So that proves this guy. Our problem. Example. And kapag pinlug in si negative 1 yung k mo, we'll find that you have this guy. So same lang. Okay? Okay? Gets? So ayan no, marami pang ibang identities si Dirac delta, and you can find them in your book, yung mga useful na identities. And this is just one of those identities na pwede nyo magamit. Okay. So ano tayo no, parang sa lab life lang, huwag masyadong mag-assume na is-zero ko lang to, ganun lang din naman mangyayari. So hindi, it doesn't work like that. You have to solve things na amazingly may lalabas na factor na 1 over k kapag nag-handle ka ng something na ganitong Dirac delta. Okay? Now, let's go back to our original problem. Now that we can have this guy, the divergence of r hat over r squared is just 4 pi Dirac delta in three-dimensional Dirac delta ang tawag dito. We plug in that. So, over some volume, and then I'll plug in this. Ito lang din yun, di ba? Yung kanina sinasolve natin. Let's try that if we can resolve the problem actually. This is cube, r hat, and then d tau ko is the volume. Now I can choose a coordinate system whatever I want. So gagawin ko na lang is Cartesian coordinates ako, then I'll write down the Dirac delta in Cartesian coordinate system. Okay? So dx, dy, dz. And then alalahanin natin na yung Dirac delta in three-dimensional is this guy. X, Y, and Z. So yung integral bounds natin will be tatlo kasi may dx, dy, dz. And I can integrate all space such that yung space covered is including x 0, y 0, and z 0. Pwede ko na may sulat negative infinity to infinity, negative infinity to infinity, negative infinity to infinity. But, ayan, all space na lang. Para cute. So, as long as yung center ng shape mo is nasa 0, then we have 4 pi. Then, Dirac delta in x, Dirac delta in y. I'm just expanding the three-dimensional Dirac delta. And z. That's dx, dy, dz. Dx, dy, dz. And since yung mga dx ko, dy, dz, they're all integrating in space and madadaanan nila si 0. So I have magiging, this is just equal to 4 pi times 1 times 1, then dy, dz, 4 pi times 1 times 1 dz, 4 pi times 1 times 1 times 1. And that gives me 4 pi. And ayun yung binigay ng right-hand side natin. Ayun yung binigay ng right-hand side natin, which is 4 pi. Now, it makes sense na dapat, intuitively, may divergence yung ganitong function natin. Okay? And we have resolved that using Dirac delta function. So, ayan. May 7 minutes pa tayo. So, makakatapos tayo ng early. So, tigil na muna ako ng lesson ngayon. Lesson next week. Tuesday will be electric field. Ayun, start na talaga tayo ng electromagnetic theory. Medyo ano pa tayo ngayon sa math. Introduce lang tayo. And mabilis tayo ngayon. Feel ko mabilis tayo. No? Na parang ang straightforward ng mga bagay-bagay. Friday. May meeting sa Friday, sorry. Okay, may export from OneNote to PDF. I'll try that. Okay. Okay, so explore ko tong OneNote. Tingnan ko kung ma-upload ko rin sa slides dahil sa canvas natin. May meeting tayo sa Friday, sorry. So sobrang dami kong meeting today. Nalilito na ako sa mga araw-araw. Tuesday pa lang pala. Okay, so meet tayo ng Friday, no? Electric field. Hindi naman holiday sa Friday. Okay. Wala namang holiday sa Friday. So, ayun.